5.7, we get to do a very familiar theorem. This theorem kids have known for several years. This is not new to you. You're going to be doing the Pythagorean Theorem. And so we're going straight back to last year when we did the Pythagorean Theorem and finding our values. The exception is going to be, hey, we're going to not change everything into a decimal. We're going to leave it in its simplest radical form. In other words, its exact answer, not its estimated decimal answer. That's what that means, okay? So the Pythagorean theorem, as you may recall, is c squared equals a squared plus b squared. C squared, C is always your hypotenuse. A and B are your legs. Legs form the 90-degree angle. The hypotenuse is always your longest side opposite of that 90-degree angle, okay? So they've given us in letter A, our hypotenuse is x, and one of the sides is 4, the other one is 6. And so it's literally just going in here and doing the math. So we've got 16 plus 36, x squared is 52. In order to get x by itself, how do you undo a square? Yep, take the square root, and then we've got x equals the square root of 52. You should always look at your radicals because they need to be in simplest form, which means if there are any perfect squares, we got to take them out and simplify them. And so I can break 52 into two pieces. The square root of 4 times the square root of 13. 4 times 13 is 52. The square root of 4 is perfect. I can take the square root of 4 and get exactly 2. Square root of 13, not perfect. It would be a decimal answer, and so I'm going to leave it in its radical form. So the hypotenuse of letter A is 2 times the square root of 13. All right, look at point or example B here. We can see clearly our hypotenuse is x. One of our sides is x minus 1, and our other side is 5. Okay? Don't let that bug you. Students all the time mess that one up, and we're not going to mess this up. So I want to make sure that we do this absolutely correctly and FOIL it out like we should. We're squaring a binomial, so we should FOIL it out. There is a shortcut. I will remind you what that is. All right, so let's write that down. All right, here's your shortcut for squaring. You can either FOIL it by doing x minus 1 times x minus 1 and doing FOIL, okay? Because it is not, when you expand x minus 1 and square that binomial, the answer is not x squared plus 1. You did it wrong. You're missing the middle step, okay, the middle term. This is the 3 steps you take when you're doing the shortcut. First of all, you square the first term. First term is x, you're going to square it. Then you're going to multiply x times negative 1. That's negative 1x. Now double negative 1x, that's negative 2x. That's your middle term. And then last step, you're going to square negative 1, which is positive 1. So x minus 1, that quantity squared, is the trinomial x squared minus 2x plus 1. And if you FOIL it out, you'll see that I'm right, because that's what you should get. All right, plus 5 squared, that's 25. All right, that's awesome. Okay, so let's keep kind of combining like terms and seeing what we've got. 1 plus 25 is 26. Okay, that's great. So really what we need to do is go about trying to solve this thing to the best of our ability. And I'm running out of room, so I'm going to move up over here, okay? Try and write a little bit smaller. Now, conventional wisdom says, hey, we should really try and get everything on one side, especially if it looks and appears to be quadratic. So I'm going to go ahead and take away x squared. Now, cool thing, it cancels out on both sides. So now it's not quadratic anymore. It's just the simple equation, 0 equals negative 2x plus 26. So I'm going to go ahead and move x to the other side, just like this, and then solve for x. And x is 13. So we did a great job. And that's what they wanted us to do, is just find x. And if you have a radical, make sure it's in simplest form. Oh, we didn't have a radical in B, so we were good. We were safe there. All right, I'm going to give you 2 points, one for each. Use the Pythagorean theorem to find x, please. And leave your answers in simplest radical form. Thank you.